For a long time, security was built around one simple idea: keep everything inside a locked network. Build a strong wall, trust what's inside, fear what's outside. But that world is gone. Today, the work that actually matters rarely stays inside one net box. It moves through cloud services, it touches vendors and supply chains, it calls outside APIs, it runs on edge devices, it reaches remote sites, and the second your system starts living that way, something important breaks. You lose the ability to truly prove what happened. You cannot confidently say the code that ran was the code you approved. You cannot prove the results weren't changed. You cannot prove something didn't peek at the data along the way. You are forced to trust the operator, the host, the environment. And in modern systems, that's a lot to trust. So the idea behind our project is simple. Instead of trusting the walls, we make trust portable. We use an open protocol that lets you carry proof with the workloads, even when it moves across massive fragmented integrations. Here is what we built to show it. We started by spinning up a small swarm in our network. Several nodes working as one. It's peer-to-peer connection. There is no central controller, no single box that everything depends on. And the trust is that network is not based on someone says it's fine. It's based on constant checking. The system is always watching the health and integrity of each node. If something looks even slightly off, that node gets cut off automatically. Not later, not after a meeting, right away. The goal is to keep a bad node from becoming a bad story. Next, we bring up a Kubernetes cluster on top of that. We give it the compute it needs. But there is a hard rule. Workloads are only allowed to run if they are inside hardware-backed isolation, and they pass a remote key attestation. In plain terms, the machine has to prove what it is, what it's running, and that's protected at the hardware level. If it cannot prove that, the workload does not run there. That's how you can route computing between different trusted zones without giving up control, even if the network gets shaky or cuts in and out. Then we put a real workload on it, not a toy demo. We deploy a large language model using Ollama. It runs like a normal service. People can use it through a web interface. They can call it through an API. The difference is what happens behind the scenes. Our prompt and model data stays confidential the whole time. They don't become visible to the operator. They don't leak through the host. They don't get exposed just because someone has administrator access somewhere. The system is built so that outside interference is not just discouraged, it's blocked. After that, we generate what we call deployment evidence. Think of it as a cryptographically verifiable record of what actually ran. This is the part that answers the questions everyone cares about, but almost nobody can prove. Can I trust this running application or not? That evidence ties together the identity of the code, the integrity of environment, and the correctness of what was executed. It's not a screenshot. It's not a promise. It's a proof you can check anytime. And finally, we set up the gatekeeper. This is a service that sits in front of the confidential application, like a verifying proxy. It's the last checkpoint. It makes sure that access is safe and that every connection is held to the same standard of proof. Users and outside systems don't just get it because they ask nicely. They get it because the system can verify that the thing they are talking to is real, isolated, and running exactly what it claims to be running. So what does this change in the big picture? It moves security away from the old idea of a fragile network perimeter and toward a decentralized peer-to-peer setup where the real trust lives inside hardware-protected enclaves. That means organizations can work together without exposing raw data. It means fewer places for attackers to hide. It means you don't have to bet everything on one central point that can fail or get compromised. Even if part of the network drops out, or even up to a third of the nodes go bad, the system keeps working, and the integrity of what's happening stays provable. That's the shift. No hoping your defenses hold. Knowing and being able to prove what ran, where it ran, and that the data stays protected the entire time.